Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video session, I would like to discuss the Module 4 Part C problems in vector differentiation, and it is in the question bank published by IARE. And now see the one by one the definitions and related problems. The first one is define gradient of a scalar point function. The scalar function means that can be represented by only phi, and it have the only magnitude and it doesn't have any direction. That is called the scalar point function. And the del is called a differential operator, which is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Del is called the vector differential operator. This symbol we call it as del. The del can be applied on both vector functions and on scalar functions also. Del can be applied on both vectors and scalar. Suppose if you apply the del on the scalar point function phi, then it is called gradient. This is called gradient. Gradient means grad phi. So what is del I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi? Or on operating each term with phi, we will get I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. And clearly it is a vector point function. The gradient is always a vector, and the physical interpretation for gradient is the outward normal vector to the surface. If phi is any function, this is a surface, then grad phi represents the outward normal vector to the surface. If phi is any surface, suppose this is some surface, then grad phi, if it is phi, then gradient phi represents the outward normal vector to the surface. That is the first thing. Second one, define divergence of a vector point function. Divergence of a vector point function. So already I told you that the del can be applied both vectors and scalars. Suppose if the differential operator del is applied on vector point function as a dot product, let f bar be any vector point function, that is f1 ij I bar plus f2 j bar plus f3 k bar, then divergence of f bar is denoted by del dot f bar. It is defined by del dot f bar. What is del? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with f1 I bar plus f2 j bar plus f3 k bar. So the dot product gives dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Clearly it is a scalar function. The divergence is always scalar. The gradient is always a vector point function. So now see the third one. Define the curl of a vector point function. The curl means it is del if you apply on vector point function as a cross product. If you apply del on vector point function f bar as a cross product, then it is defined as curl f bar. Curl f bar is nothing but del cross f bar. So how we can calculate I bar, j bar, k bar? Del means it is the differential operator. Already I have mentioned here. Del is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dou by dou x coefficient, I bar coefficient dou by dou x, that is the first one. J bar coefficient, that is dou by dou y, second term. K bar coefficient dou by dou z. And coming to the vector f bar, I bar coefficient f1 and j bar coefficient f2, k bar coefficient f3. And on expanding, this will give you a vector, and this is curl f bar is always a vector point function. And expanding this I bar into dou f3 by dou y minus dou f2 by dou z minus j bar into dou f3 by dou x minus dou f1 by dou z plus k bar. Clearly it is a vector, and this is called the curl f bar, div f bar, and it is gradient. So del can be applied. If you apply on scalar function, then it is called gradient. If del applied on vector function as a dot product, then it is called divergence. If del applied on f bar as a cross product, then it is called curl f bar. Now state Laplacian operator. Laplacian operator. Suppose if del is a differential operator which is a I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, and del is another del dot del. Both are vector point function. Del bar, that means what? This is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, dot product with I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Suppose if del square means it is called the Laplacian operator. I bar dot I bar 1 dou by dou x of dou by dou x, that is dou square by dou x square. Dou by dou y of dou by dou y, that is dou square by dou y square. Dou by dou z of dou by dou z, that is dou square by dou z square. This is called del square, and which is called the Laplacian operator. So clearly the resultant will give, suppose if del square phi, this is called the vector scalar point function. Del square is the scalar. There is no I bar, j bar, k bar. And if you apply on phi, then it will be the scalar point function. Here del square is called the Laplacian operator. That is the definition number 4. Now find curl f bar, where f bar is equal to gradient of this one. So curly grad f bar, grad phi is 0 always. Then I will show this. So curl f bar, you have to calculate where f bar is equal to gradient of x cube plus y cube plus z cube minus 3xyz. That is given. So then gradient means I bar dou by del of x cube plus y cube plus z cube minus 3xyz. First I would like to find f bar. So I bar into dou by dou x of the entire term plus j bar into dou by dou y of entire term plus k bar into dou by dou z of entire term. That is I bar into dou by dou x of this one, 3x square minus means 3yz, this will get, plus j bar into dou by dou y of entire one, 3y square minus 3xz, plus k bar into dou by dou z of an entire term, 3z square minus 3xy. So this is the vector f bar. Now what we have to calculate is curl f bar. Curl f bar means del cross f bar. That is determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. I bar coefficient 3x square minus 3yz. J bar coefficient 3y square minus 3xz. K bar coefficient 3z square minus 3xy. With respect to z we are doing 3xy. So I bar into dou by dou y of this one minus 3x minus dou by dou z of this one, that is plus 3x. So it is symmetrical, so you can use sigma notation, sigma 0 bar, that is equal to 0 bar. The curl grad phi is always 0, and here also you can show that curl grad phi is equal to 0 bar. Next, see the sixth problem. Find the angle between the normals to the surface xy is equal to z square at the points 4, 1, 2 and 3, 3, minus 3. So what is angle between the surfaces means? Angle between their normals. Angle between the normals already is given, angle between the normals. So find the normal vector for the first surface at this point. Similarly, find the normal vector for the surface at this point. That is, let phi is equal to xy minus z square. Then grad phi. What is grad phi? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of xy minus z square. So how you operate I bar into dou by dou x of this one? Only y. Dou by dou x of x1 no y z square 0 plus j bar into dou by dou y of this one, that is x, plus k bar into dou by dou z of this one, minus 2z. So what is this? So second problem. So sixth problem. What is the function? yi bar plus xj bar minus 2z k bar. This is the gradient of the surface. This is the normal vector to any point. But grad phi at 4, 1, 2 you calculate. That is I bar plus 4j bar minus 2z, 2 into 2, 4k bar. That is the first vector. Similarly, find at the point 3, 3, minus 3. 3, 3, minus 3. So, on substituting 3i bar plus 3j bar minus 2, 3, 6k bar. Z is minus 3, so this is plus Z minus 3. 2 into minus 3 minus 6 plus 6k bar. So, this is the second normal vector. The first normal, second normal. So then what is to be calculated? Cos theta is equal to n1 bar, that is I bar plus 4j bar minus 4k bar, first vector. Angle between the two surfaces. Formula cos theta is equal to grad phi 1 dot grad phi 2. What is grad phi 2? 3i bar plus 3j bar plus 6k bar by square root of, for this magnitude, 1 plus 9 plus 9. Oh, sorry, 1 plus 16 plus 16. 4 4s are 16, 4 square 16, 1 square. Here 9 plus 9 plus, what is this? 6, 36. So in the numerator you will get 1 I bar dot I bar 3 plus 12 minus 6 4s are 24. 6 4s are 24 by root of 33 into root 36 plus 18. So 54, root 54. So this value 15 minus 24, that value by this one is the cos theta value, and theta is equal to cos inverse of, that is called the required angle between the two surfaces. Next, I'm coming to the seventh problem. Find a unit normal vector to the given surface at this point. What is unit normal vector? Unit normal vector. Unit normal vector means what? Grad phi by magnitude of grad phi. Grad phi is only normal vector. Unit normal vector is obtained by grad phi by magnitude of grad phi. So first find grad phi. What is grad phi? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of, what is the function? X square y plus 2xz minus 4. So on substituting I bar into dou by dou x of entire one, 2xy plus 2z plus j bar into dou by dou y of this one, x square only, plus k bar into 2x plus k bar into dou by dou z of entire. This is 0, this is 0. Z become 1, 2x. So now grad f at the point 2, minus 2, 3. So substituting x2, y minus 2, minus 2 2s are 4, 2s are 8, I bar into minus 8 plus 2z, 2 3s are 6, plus j bar into x square 4 plus k bar into minus 4. Or this is minus 8 plus 6 minus 2i bar plus 4j bar minus 4k bar. This is grad phi at that point. Now magnitude of grad phi is root of 4 plus 16 plus 16, that is 36 plus 40, root 40. Sorry, 32 plus 4, 38. That is magnitude of grad phi. So the unit normal vector is equal to grad phi by magnitude of grad phi. So this vector by this is the required unit normal vector to the surface. So last three questions are remaining. Define irrotational vector. What is irrotational vector? If curl f bar is equal to 0 bar, curl f bar is always a vector. If curl f bar is equal to 0 bar, then the vector is said to be irrotational vector. Similarly, if div f bar is equal to 0, then f bar is said to be solenoidal vector. If div f bar 0, then it is solenoidal. If curl f bar 0 bar, it is a irrotational vector. Next, to show that this is irrotational vector, see the 11th one. That means what you have to calculate? Curl f bar. That is del cross f bar, determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. The last values yz, zx, xy. So that is I bar into dou by dou y of this one x minus dou by dou z of this one x. So summation, it is summation 0. That is 0 bar. 0 bar means what? Curl f bar 0 bar means it is an irrotational vector. Similarly, I will see that this is the big derivation, but even though I will try grad f of r. Grad f of r means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of f of r. So I am writing sigma I bar into dou by dou x of f of r. So that is summation I bar into dou by dou x of f of r, that is f dash of r into dou r by dou x. F dash of r into, with respect to x we are differentiating partially. So I bar into f dash of r into dou r by dou x. But what is dou r by dou x? X by r. Dou r by dou x is x by r. So on expanding, what we will get? Summation I bar into f dash of r into x by r plus I bar into f dash of r into y by r plus j bar plus k bar into f dash of r into z by r. So what is the common term? F dash of r by r is common on the brackets xy bar plus yj bar plus zk bar. But what is xi bar plus yj bar plus zk bar? That is r bar. So r bar by r into f dash of r. That is the required result on the right hand side, r bar by r into f dash of r. So these problems comes under vector differentiation. So in this main topics are gradient, divergence and curl and their physical interpretations, and there are some problems and operations of del with like as curl and like divergence like gradient. So with these few problems, I conclude my session, and in the next class I will come to with vector calculus, vector integration topic, and these problems have been taken from the question bank of the course Differential Equations and Vector Calculus, and the regulations is BT 23 published by IARE. So thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.